after we discussed just the other day with the Chief Scientist of Australia the need to encourage more women into STEM subjects, into science and mathematics and engineering. You're going to meet a quite extraordinary researcher who actually shows a really optimistic path towards the new generation of long-term batteries.
You're with Virginia on ABC Radio Melbourne.
I'd like you to meet Mahdokht Shaibani, who's a research fellow at Monash University's Department of Mechanical and Aerospace Engineering. Mahdokht Shaibani is an Iranian-born Monash University engineer who's invented a really interesting replacement to lithium-ion batteries. Mahdokht, good to talk to you. Good morning.
Good morning, Virginia.
Tell us when you came over to Australia from Iran. How old were you?
I was 26, so it was around 8-9 years ago, yeah.
And had you done your studies in Iran, had you?
Well, I did my bachelor's and master's degree in Iran, and then I came to Australia to do a PhD at engineering at Monash University.
And what sort of engineering did you do your PhD in?
Mechanical engineering, yeah.
And how did that lead you to this replacement for a lithium-ion battery?
Yeah, so when I was actually applying for PhD studentships here and there, I got offered a number of places, a number of universities. And the one that I got from Monash University was a project on batteries. And it was actually a no-brainer for me. The second I received the offer, I told myself, this is what I was going to do. This is what I always wanted to do, to make something that has an immediate impact on our daily lives. And I remember I told myself, I always hear my parents, everyone around me, basically the general public, talk about how they want better batteries, how they want faster batteries, more powerful batteries, cheaper batteries. So yeah, that's why I took the PhD. And then the project was on lithium sulphide battery. It's one of the emerging battery technologies. And,
it is. I'd actually not heard of lithium ion that doesn't need cobalt or rare earth minerals, and that's what this particular battery technology doesn't rely on. Is that right?
Yeah, that's actually very true. So I'll give you a quick background about lithium sulphide battery. So it's fundamentally different than the commonly used lithium ion batteries. In lithium ion, as you mentioned, we rely on heavy metals such as nickel and cobalt, which are excellent for storing and delivering energy, no doubt, but they are known to pose tremendous environmental and humanitarian risk. Lithium sulfur, on the other hand, and as the name suggests, it relies on sulfur, which is an abundant, incredibly cheap and non-toxic element.
Isn't there, I also read in preparing to talk to you this morning, Mahdokht, that doesn't sugar play a role in the trick or the cleverness involved in this new technology?
Yeah, that's true. So as awesome as lithium sulfur is in storing energy in a cheap fashion, the technology has been held back by issues around the tendency of sulfur to leave its designated place in the battery, travel to the other side of the battery and damaging basically the other electrode, and that causes a limited lifetime for the battery.
Right.
So what we needed was to dope the sulfur electrode with an additive that keeps the sulfur at its place. And we do have this young female engineer in our team, Yingyi Huang, who found a 35-year-old geochemistry report that described how sugar can help soil retain sulfur compounds by forming a strong chemical bond with them. She brought up the idea to the team, and immediately we found it brilliant. Because, similar to sulfur, sugar is cheap, it's non-toxic, so we could have maintained our target of making a green battery electrode. And then the other ingredients of the battery were basically carbon and water. So pretty green, pretty cheap, yeah. So,
and does that also mean that the batteries can either break down in a non-toxic way or be recycled and reused?
Yeah, that's true. So as opposed to lithium-ion batteries, which recycling is a major challenge, this one could be easily recycled and the ingredients could be back to use. And thanks to the small dose of sugar, now
a spoonful of sugar. It takes a spoonful of sugar, right?
Yeah.
just like
I
the song
think it was,
goes.
Yeah.
That's amazing. Do you have any sort of relationship with a commercial partner? Have you got someone from industry involved who can commercialise this?
Yeah, so for this project, I would call it program, it's better because it's been running for quite 5-6 years now. We've been partially funded by industry and partially funded by the government.
Right.
Yeah, now the industry is looking at basically commercialization, yeah.
Okay, so they're looking at manufacturing and selling.
Yeah.
That's just really quite amazing.
Yeah.
It's a wonderful invention. Does it potentially mean that such batteries could be used in cars? Could it mean that we could use those batteries to power a car for long distances?
Yeah, so if I look at the specifications of the current lithium sulfide batteries and also the projected specifications of the future ones, I would say that this technology would do a great job in powering large electric vehicles. You may find it interesting to know that almost half of the price of an electric vehicle is the cost of the battery. And we believe if we offer a replacement for lithium ion, which is not only cheaper, but requires less number of charges during driving long distance, for example, from Melbourne to Sydney, Melbourne to Perth, it will significantly boost the take-up of battery-driven vehicles. Yeah.
That's really remarkable and a wonderful, wonderful development. Well, the Chief Scientist of Australia, Mahdokht Shaibani, told us that it's crucial that more women get encouraged or feel confident and able to study STEM subjects to end up in a place of research and development like you have. What's the thing in your mind? What's the key thing that would actually clear the path for women to feel like they were accepted and welcome and able and competent enough to take this on?
Yeah, well, I honestly can't think of any fundamental reason why we shouldn't have more female engineers in Australia. It's a bit of a sad statistics, but the proportion of women in engineering in Australia is 12%, which compared to where I come from, Iran, it's like 50% there. So,
were there many women studying? As you were studying engineering in Iran, your home country?
Yeah. So when I was doing my undergrad studies in Iran, the proportion of girls in my class was 60%.
60% women?
Yeah, 60% women. So, yeah, I guess I was a bit surprised when I first came to Australia. I mean, I didn't do any coursework studies here in Australia, but I actually do teach a fourth-year unit at the Department of Mechanical Engineering at Monash.
Good on you. I'm glad you're teaching too. Mahdokht, really good to meet you. Thanks so much for telling us your story. It's fascinating.
Thank you so much. Thanks for having me.
Mahdokht Shaibani, who's a research fellow at Monash University's Department of Mechanical and Aerospace Engineering. Dr. Kathy Foley, who's Australia's Chief Scientist, called on this program for women to feel like this is the path that they can follow, that there actually is a study pathway, research, and also a business pathway for them if they start to study these subjects and if they're made to feel more included. And I think Mahdokht is a perfect example of that actually playing out.